Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. In this video, we're going to do a question from the November 2018 Grade 12 Physical Sciences Paper 2. This question deals with the strength of acids and the equilibrium constants of acid-base reactions. So we're given two chemical equations involving reactions between acids and bases, and we're told that the equilibrium constant is greater than 1 for both of these reactions. Then the question asks us to list the acids in order of increasing strength, so weakest to strongest, based on the two chemical equations given. To answer this question, you need to recall the Bronsted-Lowry definition of acids and bases. So according to this definition, an acid is a proton donor and a base is a proton acceptor, where a proton is an ionized hydrogen atom, H+. So in these equations, the acid is the substance that donates a proton to the base, forming its conjugate base and another acid. And then additionally, we're given the equilibrium constants for both equations, and they are both greater than 1. So the equilibrium constant can be written in terms of the concentration of the products over the concentrations of the reactants. So that means that equilibrium, the concentrations of the products are greater than the concentrations of the reactants. So the acids have ionized to a large extent, and that is a characteristic of strong acids. So we can immediately conclude that the acids on the left-hand sides of the equations are stronger than the acids formed on the right-hand sides of the equations. So let's look at the equations we have and our options. So in the first one, H3X reacts with hydrogen carbonate to produce H2X- and carbonic acid. So the H3X becoming H2X- means that it donates a proton to the hydrogen carbonate, and the hydrogen carbonate accepts the proton and forms its conjugate acid, carbonic acid. So that means that the H3X is the acid for the left-hand side of the equation, and the carbonic acid is the acid for the right-hand side of the equation. So we know from the equilibrium constants that the acids on the left are stronger than the acids on the right, so we can immediately say that H3X is a stronger acid than H2CO3. Okay, so now we need to look at our second equation. On the left-hand side, the hydronium ion donates a proton to H2X to become H2O, its conjugate base, and H2X- accepts the proton and becomes its conjugate acid, H3X. So H3O+, the hydronium ion, is the acid for the left-hand side of the equation, and H3X is the acid for the right-hand side of the equation. Once again, from the equilibrium constant being greater than 1, we know that the left-hand side acid has ionized to a much greater extent than the right-hand side acid, so that means that H3O+ is a stronger acid than the H3X. Okay, and if H3X is stronger than the carbonic acid, we have our acids in order of increasing strength. So the weakest acid in this case will be the carbonic acid, and the only option with the carbonic acid as the weakest acid is option B, and that also tracks with what we have for the H3X and the H3O+, because the H3O+ is the strongest acid, and then H3X is the medium strength acid in this case. Okay, so before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.